OGVis is a lightweight prototype tool for visualizing game telemetry data in the Unity engine. Our demo framework includes customizable logging and visualization utilities. Before a playtest, developers can configure settings for data logs, including player ID, position sample rate, and which button presses to record. Game events can be logged by embedding single-line hooks in gameplay code. When the game is started, the logging manager will automatically attach to the player and start streaming data to a log file. After a series of sessions have been conducted, the logs can be visualized using the OGLog visualizer. The visualizer can load batches of log files from a user-specified directory and parse them to extract telemetry and event records.
All forms of data can be filtered to create a custom display. Individual players, input, and gameplay event types can be enabled and disabled at will. Additionally, the colors used to encode each category can be specified by the user. Player paths can be visualized both individually and as an aggregate. The aggregate view can be used to quickly gain a sense of where players spent most of their time, or if any areas in the level don't experience much traffic. It can also be used to quickly compare at a glance how one or more players stacked up against the average or combined traversal of all other player logs contained in the aggregate. Player pathing can become confusing to interpret when looking at multiple or convoluted paths. To help mitigate this, users can flatten one or more axes to reduce 3D confusion, or zoom out and use Unity's in-scene orthographic view to help provide an overview of player trajectory.
When dealing with larger scale data, however, the primary use of the viz is to aggregate clusters of input and game events. For example, a user might be curious where players triggered an ability most often, or if they were prone to button mashing at any point. Individual events can be viewed for all enabled players, but this becomes unmanageable quickly. When aggregation is enabled, the user can specify a radius to create event clusters, which are scaled to reflect the number of events in the cluster. This provides a summary distribution of key game events, helping developers to understand hotspots of activity and identify potential design issues. In our future work, we hope to expand upon this system by incorporating temporal semantics, including utilities for annotation and improving in-scene interactivity. Thanks for watching.